Good evening, everyone, and welcome to the 2021 Southeast Michigan Fishery Workshop. My name is Mary Bowling, and I'm an educator with MSU Extension Sea Grant Program. Michigan Sea Grant helps to foster economic growth and protect Michigan's coastal Great Lakes resources through education, research, and outreach. It's a collaborative effort of the University of Michigan and Michigan State University, and it's MSU Extension Sea Grant part of the NOAA National Sea Grant Network of 34 university-based programs. So MSU collectively acknowledges that its campus and statewide offices occupy the ancestral, traditional, and contemporary lands of the Anishinaabeg that were ceded in multiple historic treaties. Through this acknowledgement, we recognize, support, and honor the sovereignty of Michigan's 12 federally recognized Indian tribes and for historic Indigenous communities and individuals. Tonight, we are going to hear from speakers regarding water levels and fisheries management in the St. Clair River, Lake St. Clair, Detroit River, and the Western Basin of Lake Erie. My MSU colleague, Justin Selden, and I have been hosting these workshops annually to allow anglers, charter boat captains, and others to hear directly from fisheries managers. You can ask questions and provide input on fisheries topics and all the different things happening on those water bodies. Justin, is there anything else that you'd like to share before we get started?
Welcome, everyone, and thank you for taking time out tonight to be with us. Just wanted to let you know that all of our speakers will be staying with us for the question and answer session at the end of our agenda. Feel free to type your questions into the box at the bottom of your screen throughout the night as you think of them. Also, we'll be recording this workshop and putting it up on YouTube so that you can share it with others who weren't able to join us tonight.
Thanks for those reminders, Justin. So we'll go ahead and jump into the agenda. Our first speaker is my Sea Grant colleague, Mark Breederland, who's going to share some information about water levels. So take it away, Mark.
Certainly my pleasure to just kind of share an update on the Great Lakes water levels. Again, it's April of 2021, and I think we've all been through quite a bit. This was going to be a major impact across Michigan and the rest of the Great Lakes communities, no matter if we had COVID or not, right? So, but it's my pleasure. I love the Southeast Michigan corridor there from Lake Huron all the way down through the very wide spot and wonderful fishing area that you're going to talk about more tonight in Lake St. Clair, the Detroit River, and into Lake Erie. So let me kind of just start, just as really a primer because of the time limits that I have here. But maybe you remember back almost 10 years ago, these happened to be in Grand Traverse Bay, but we are at record low levels. And I was working with the Corps of Engineers and others to help do some education programs because we were fighting very low level issues. There was a guy that almost didn't get his boat off his seasonal hoist there because it had been dropping so quickly there in September and October. Here's another shot of Lake Michigan Huron, and this is in Grand Traverse Bay too, but this is when it was not at the record low, but it was very low period in the 2000s. And then here in 2019, not quite at its record high. Maybe you have different memories more recently, certainly well aware of the St. Clair River ice jams and flooding. This certainly happens periodically, but it was pretty significant here in just this last winter. Obviously, places like Marine City, East China Township were quite impacted. And of course, we had a year-long inundation almost when you think of Harson's Island, Clay Township areas, those kinds of places. Maybe your memories are something like this. This is over in Saugatuck, Michigan, but these are actual sand blocks here that were blocking the city boat launch. So they had closed boat launches in places like this. And you can see the water line along here where that was almost keeping water from going into the part of downtown Saugatuck. So lots of different memories of different impacts from this high water period. So I wanted to start with this screen here to kind of look back. This came from the Great Lakes dashboard, and this is 2013, and I've put here Michigan Huron, St. Clair, and Erie all on this one chart. But again, if you kind of look, these are the monthly averages. The red line is the very long-term average here. And of course, these lines, these stair steps really are the yearly averages as we kind of came up, and then a big jump here in 2019. And then even higher on Michigan Huron in 2020. But we could see this happening. And this was there was very little decline here. So we peaked on Lake Michigan Huron in July, and then we've had a good decline, a good seasonal decline, where you haven't seen that as much in these past years. So I'll mention a couple things. These little red bars are the actual forecast on this. So you'll see that Lake St. Clair kind of follows the same trend with a few more bumps in it. Obviously, that is the most recent bump here is in January 21, and that's related to the ice dam. And Lake Erie had some different peaks. Here's a real sharp peak and then back down. And then again, their highest levels were actually in 2019, not quite as high in 2020. So that's kind of the big macro picture of where things have been basically in the last 10 years. And it's a record rebound and the highest rate of increase that we've had. So back to the primer, just to orient everybody again, you know, with Lake Superior being the highest elevation down through the St. Mary's, Michigan Huron with the deep connection at the Straits of Mackinac. And this is your wonderful area here from Port Huron, here's Detroit, and down into Lake Erie. Obviously, further down, we got the big drop into Lake Ontario, and then some dams here. Lake Ontario is a bit more regulated, obviously, than the other lakes, and then out into the rest of the system. Well, the Corps of Engineers and NOAA jointly measure, and they use these long-term gauges. Michigan Huron has 6 gauges, including the one at Harbor Beach, which is the long-term master gauge. And then we have data going back to 1860s for that particular gauge. I didn't show on this map the 2 that are on Lake St. Clair that are used in the long-term static water level measurements. There's actually 4 that are used binationally on Lake Erie. There's Port Colborne and Port Stanley on the north side, and I think it's Toledo and Cleveland. A gauging station is set up here so that they take in water through gravity, and it's a stilling well. Again, we're looking for the static water level because we know there's huge shifts depending on the wind and the waves and atmospheric pressure too. But here's the measuring stations. There's battery backups, and the information's transmitted by satellite up the chain. Again, the factors impacting water levels are the inflow lake from the upstream lakes. Obviously, the evaporation is a key, the precipitation directly onto the lake, and the runoff from the rivers into the lakes. And again, these are kind of words that the Corps of Engineers and other supply managers. The net basin supply is those 3, and then the net total supply includes the inflow and the outflow, the inflow from the lake above. So this is the typical season. I think everybody knows this. We've just come out of the melting season, the snow. We see the lakes are going up. They are all rising now. In fact, in the last kind of couple weeks, Lake Michigan Huron's gone up a little bit over an inch. It's going to continue. The long-term average is 12 inches on Michigan Huron. We've had crazy years of 22-inch rises and lower years. It looks like this year maybe even a little bit lower than the average than 12 inches. So as the water heats up in the summer, the fall is our key time of evaporation when the cold air masses move over the system. I just wanted to give this one slide because I think it tells a big story here. This is the gauging station that's at the Grand River in downtown Grand Rapids. And they've got, this is a spaghetti plot here, but they've been measuring all this information since the early 1900s. And basically the last few years, 17, 18, and 19, that was just crazy high. And then 2020 was actually double the discharge. And again, that's enough water to raise Lake Michigan Huron about 2 inches. So it was very, very wet. Now, these are the longer term hydrographs here. Again, this is Lake Michigan Huron back into the 1860s. You can see some periods of high water. From 1918 on, we have this long-term average. That's the red line, periods of low here in the Dust Bowl years in the 30s, the 60s, really high peak there in 86. And this long extended period of very below average here, and then this crazy peak, which we just talked about for the last 10 years. So you'll see Lake St. Clair, it didn't start as early as 1860 with their gauging. You can see some of the low years here in the 30s, again, the 60s, the peak again in the mid 80s, low, and then back up. So fairly similar, different amounts of variation. This is Lake Erie, very low again in the same period. And then this crazy peak. So that's the broad picture. These are the most recent forecasts. And again, the red line here indicates what actually was measured. These little lines up here are the record highs. So again, this is Lake Michigan, Huron. And all these highs, 2020, 2020, these used to be 1986, and they were all pushed up several inches. So every month of 2020 from January to August was a new record high. So you can see now that they're pushed up there. This is our most recent forecast. This is the 6 month, this little kind of green line here. And then the error bars. As you get out further, it's almost like asking the National Weather Service, what's the forecast for the weather 2 weeks from now? 2 weeks from now, a lot of error. 2 days from now, they're very good. So the first few months are quite accurate on this. And again, this is the long-term average and the record lows. So I'll show you the same thing here on Lake St. Clair. Here's the 6 month official forecast. That's all the models officially forecast, but I do have some other information to just share real quickly. And Lake Erie as well. You can see it set some really highs here in 2019, some very highs here in 2020 as well. And then here's the current forecast, quite a bit lower actually than the record highs. I tell people, I just wanted to give you an analogy. Lake Michigan Huron is one lake, 6'4" variation, but it's like a skyscraper that's 100 stories tall. And we had the bottom floor in 2012 or so, and we hit the top of the peak here. Basically, the top of the thing was in July of 2020, top of the skyscraper. But we did have 1 month, it was just one crazy month in October of '86 that we hit the top of the radio tower. But we have dropped some. We're probably in the 75th floor now, but our real sweet spot for living is the 40th to 60th, plus or minus a foot. So here is the last information I wanted to share, these last 3 slides. Besides the official 6 month forecast, which ends in this kind of error bar here in this kind of salmon color, this is the official forecast. The Corps now puts out this product. It's kind of an outlook, and it shows another 6 months past that in a range, kind of this long-term outlook and different scenarios. And they've been able to look at scenarios that match the different time periods. So 87, 88 and 15, 16 seem to be good parallels. It's interesting to see what actually happens. So right now, we seem to be following the 15, 16 kind of a model. So this is the end of the forecast. This is all much more speculative, but it gives you an idea that we probably are not going to be at the high end of this gray error bar, nor at the low end, but probably right in the middle. Wanted to share the same on Lake St. Clair. Again, the official forecast is right here in the middle. Now on this one, you can see the 2015-16 is a bit higher, and the one in 87-88 is a bit lower. So we'll be watching to see how that comes out. We did have a very dry January all across the Great Lakes. So I'll close with the Lake Erie forecast and outlook here. Here's the official 6 month forecast. Again, kind of peaking in, early summer, probably June for Lake Erie, and then trending downwards. So we are definitely going to be lower, and I hope that we have good access and the boat launches are available and the fishery station doesn't get flooded and all those kinds of things. So thanks for letting me share this little primer, Mary. I'm just a couple minutes over, so I'll stop sharing and we'll turn it back to you.
All right, thanks, Mark. It is good to see those water levels coming down, even though they're still up above that long-term average. But I know folks are happy to see them coming down. So appreciate that information from you.
Thank you.
So next up, we have Jan Michael Hessenauer. He's a research biologist with Michigan DNR, and he's going to share the results of the Muskie Acoustic Telemetry Project.
Good afternoon. My name is Jan Michael Hessenauer. I'm a fisheries research biologist with the Michigan Department of Natural Resources. I'm here today to share some of the Muskie acoustic telemetry work that we've been doing. On behalf of my co-authors, I'd like to thank you for your interest in our study. I'd like to take a moment to briefly acknowledge the project partners. This has been an extremely collaborative project, and we're really grateful for the assistance we've received from the Ontario Ministry of Natural Resources and Forestry, USGS, Ohio DNR, GLADOS, and then a number of angling partners, including the Michigan Muskie Alliance, Muskies Inc., Lake St. Clair chapter, Muskies Canada, and Muskies Canada Bell River chapter. I'd also like to take a moment to shamelessly plug our new research article that just was published online in Journal of Great Lakes Research. So if you would like a preprint, please feel free to reach out to me. My contact information is there, and will be presented again at the end. But a lot of what I'm going to talk about today is discussed in much greater depth in this manuscript. So today we're going to be focusing on the St. Clair Detroit River system. This system is the connecting water between Lake Huron and Lake Erie. It's comprised of the St. Clair River, Lake St. Clair, the Detroit River, and then the west basin of Lake Erie. This system has historically had a very robust muskie population. We've got some really cool historic photos from our office. This one was taken in the North Channel of the St. Clair River up here in the early 1900s. This photo here was from Tommy's Boat Library, which is at the foot of Alta Road in Detroit, right where Lake St. Clair becomes the Detroit River. You can see quite a few muskies from a tournament that occurred there. And in contrast to many of the other Great Lakes muskies population, for some reason, this system has maintained a very robust muskie population. And it's you know, photos like this are very common. This was a fish that we caught electrofishing, but it's a well-known muskie fishery, probably one of the best ones in the entire world. So despite the apparent robustness of the population, we really don't know the population size, and this makes managers and scientists a little bit uneasy. All the data that we get on the population is extremely fishery dependent, so based on things like charter reporting and creel data, and we don't have an independent way of verifying the status of the population. Another question we have is whether or not there are population boundaries within the system. So is the system represented by a single large population, or are there multiple subpopulations occurring in the system? And that has implications on trying to estimate the population size as well. One of the other questions that's really important to my agency is where are fish spawning? So the Detroit River is the source of Michigan's muskie egg broodstock for stocking purposes, and it would be nice to identify a few other areas where we can reliably collect spawning fish to add some resiliency and robustness to the program. Acoustic telemetry is a tool that's well suited to address all of these questions, and is sort of what initiated this project to begin with. So I'm sure many of you are familiar with acoustic telemetry, but for those of you that are not, it involves surgically implanting a tag into the fish. So this is a series of photos that shows that process. A small incision is made. The tag is inserted, which is about a little bit larger than AA battery. And then finally that incision is closed. And after the fish recovers, it's released back into the wild. And it's then broadcasting a unique to that fish signal, which can be detected by listening stations that are located throughout the lake. Well, one of the potential flaws of any telemetry study is that you can only find fish where you look for them. So thanks to the research collaborative that is represented by GLADOS, we're looking for fish at a spatial scale that's really never been done before. So each of these yellow dots represents one of a receiver that's part of the GLADOS network. So our fish could potentially be detected on any of these yellow dots, and we could then query the database and find the detections of our fish. Currently, we've released about 140 tagged fish at these locations represented here on the slide, but we focused up here on Anchor Bay in Lake St. Clair, the Canadian South Shore at the Thames River and Bell River, Thames River here, Bell River here, and then in the Detroit River at Belle Isle and Wyandotte locations. Today we're going to specifically focus on 58 fish that have been at large for the largest amount of time and that had the best data with the fewest gaps in it. So we have the highest confidence in the locations of these fish. I should also note that the Anchor Bay and Detroit River fish were tagged in the spring during spawning, and Bell River and Thames River fish were tagged largely in the fall. So there is some sort of some seasonality differences among these tagging locations as well. So this figure shows detections to date. Each dot represents the mean monthly average of an individual fish's location. I really like this metric because it provides data that's coarse enough to really not pinpoint the location of fish. That's something that our angler partners have been worried about, but still shows the patterns of movement very nicely. Over the course of the study, the mean daily movement rate for fish has been about 881 meters, and the season has been the only factor that's been significantly affecting that movement rate. So fall tends to have the greatest movement, spring and summer are roughly equal, and then winter has the least movement. You will notice a few fish here that are appear to be on shore, and again, that's a function of this mean monthly average location. So these fish presumably move from, like Lake St. Clair to Lake Erie or vice versa, and that's why when you take the average of their location, they end up here on shore. But really widespread movement of fish throughout all of Lake Erie, and then some typical patterns of fish concentrating in the South Shore, and really interesting to see movement here into the West Basin of Lake Erie as well. This figure shows the residency of fish, relative residency based on water body and jurisdiction. So you can see that fish tagged in Lake St. Clair, for example, tend to spend the majority of their time in Lake St. Clair. What's interesting is the Detroit River fish seem to split up their time roughly evenly among Lake St. Clair, Lake Erie, and the Detroit River. Switching to jurisdiction, we see some differences between fish tagged in Anchor Bay. They spend about half their time in Michigan waters and the rest of their time in Michigan and Canadian waters. Fish tagged in the Canadian waters of Lake St. Clair tend to spend most of their time in Ontario waters. And again, a similar pattern in the Detroit River fish, where about half their time is spent in Canadian waters and then the rest is split between Michigan and Ohio. But this certainly has some implications given that Michigan, Ohio, and Ontario all manage muskies in a slightly different way. And the fact that these fish are frequently moving among those jurisdictions may be something that managers want to consider in the future. This slide shows the same data as the previous slide, but broken out here now by individual monthly average location from each tagging location. This kind of lets you see the patterns that are occurring in those populations a little bit more clearly, and some interesting patterns emerge. So again, Detroit River fish splitting their time between Lake St. Clair, the Detroit River, and then Lake Erie. What's neat is that the Anchor Bay fish and Bell River fish maybe look a little bit more similar to one another than the Thames River fish. And again, remember that Anchor Bay fish and Bell River fish were tagged at different times of year. So it could be that they are, indicative of a similar population, but maybe a little bit different than the Thames River fish, which is something that's really neat to see come out in data like this. So a couple of interesting anecdotes that I wanted to share. One being that we've had very few detections of fish in the St. Clair River, and this is somewhat surprising to us because we know that there's a robust population of muskies in the St. Clair River, yet none of the fish that we tagged seem to be moving into the river very frequently. We've got a few odd detections up here, but really no heavy movement of fish into that river, which may suggest that there's a population boundary exists with relatively few fish from at least the lake moving into the river, and we're hoping to tag some more fish in the river coming up here in the future. The other thing that we've noticed is that fish are frequently returning to their tagging location regardless of the season tags. So fish tagged in the spring when we expect them to be spawning are returning to those areas, presumably to spawn in future years. But the fish tagged in the Canadian rivers areas are also returning to those locations, even though that's those fish were tagged in the fall, so that's likely not a spawning behavior, and maybe indicative of some other behavior pattern, which is pretty interesting to us. So moving forward, we'd like to use some of these fish's movement patterns to assign them to populations, and in quotes there. Basically, they're fish that are behaving and moving in similar locations, and use those populations to generate a population estimate for each one, and then ultimately the system as a whole. We are also going to be expanding the receiver array in Lake St. Clair thanks to an equipment loan from GLADA. So up to now, we've had about 12 receivers in Lake St. Clair, and we're going to be bumping that up to about 40. So that'll provide a lot more spatial coverage in the lake, and will benefit not only this muskie study, but all of the acoustic telemetry studies that have been going on in Lake St. Clair and throughout the system. So with that, I'd like to thank you for your attention and would gladly take any questions. Again, there's my contact information. And I'd like to once more acknowledge our funders who've been a big part of this project. So thanks a lot for your time, and I'll gladly take your questions.
Thanks, Jen Michael. So folks, if you can go ahead and enter any of your Muskie questions below in the box, and then we'll get to them after we hear from all of our speakers. So our next speaker is Brad Uttrup, an DNR fisheries technician, who will talk with us about the Northern Mad Tom assessment that he's been working on.
Hello, my name is Brad Uttrup from the Michigan Department of Natural Resources, Lake St. Clair Fisheries Research Station. Today I'll be presenting work my colleagues and I have done investigating the population of northern mad toms in the St. Clair River. Mad toms are a group of North American catfish belonging to the genus Noturus. While they are a very diverse group, they are often not very common or abundant. Michigan is home to 5 of the 25 species in the genus. They are generally very small and secretive in nature. They inhabit small to large rivers, with a few species also living in lakes. They are almost always associated with complex structure where they hide out during the day. This group of catfish require clean water and quality habitat. Their presence or absence can tell us a lot about a water body. They also possess venom glands along their spines that deliver painful stings similar to a wasp as a defense mechanism. The northern mad tom is listed as a state endangered species. In Michigan, they are only found in the St. Clair River, Detroit River, and the Huron River. The place where these mad toms call home does not make studying them very easy. The St. Clair River is a difficult place to envision through facts or even pictures. This waterway forms the northern stretch of the connecting waters between the upper lakes and the lower lakes. I often have people picture Niagara Falls and that tremendous amount of water to realize that same volume is passing by on the St. Clair River at any given moment as well. To sum it up, it's wide, it's deep, and it's cold with a very strong current. It's listed as an area of concern in the Great Lakes due to decades of environmental impacts from industry, shoreline armoring, and commercial shipping. There have been habitat improvement projects in recent years, such as shoreline restoration and artificial reefs. Our primary goal during this annual June survey is to monitor lake sturgeon in the system. We use baited set lines set overnight in the north channel of the river. Water depths range from 18 to 60 foot deep. In 2010, we began attaching minnow traps to each of the ends of the set lines to try to capture northern mad toms. Although not perfect, this addition has allowed us to get our hands on enough mad toms over the past decade to learn some interesting things. In the early years of trapping, we had moderate success. All things are relative, but at that time, we were very happy with the 10 or 12 fish we would catch each year. In 2016, we switched from using various cheese chunks as bait to night crawlers suspended in bait bags inside the trap. That year, we caught nearly 300 mad toms. We have continued to use the night crawlers as bait and have seen declining catches since that tremendous high. It appears there was a boom in the mad tom population that we were able to observe. During 2016 and 17, we also marked 280 fish and have only ever seen 2 of those marked fish again. This increased catch and lack of recaptures led us to believe the population in this stretch of the river was very robust and could handle sacrificing a few fish for more comprehensive work. In 2019, we sacrificed 27 fish for age, growth, diet, and fecundity work. I also want to point out that declining catch that we see in this graph is exactly what we would expect to see from natural mortality. Most of the fish caught in the traps are around age 3, and the life expectancy for these fish is only 5 or 6 years. During preliminary work, we examined pectoral spines, dorsal spines, and otoliths. We found that pectoral and dorsal spines yielded similar results in our age work. We proceeded examining only dorsal spines moving forward, as they would be considered the only non-lethal structure we felt comfortable using. We extracted otoliths from the sacrifice fish to compare with the dorsal spines. There are always trade-offs with different age structures. The otoliths proved easy to read, but their tiny size of approximately 1 millimeter led to issues with accurate cross-sectional cuts. The dorsal spines have a hollow core that can hide the first annulus. Pictured here are otolith and dorsal fin cross sections from the same 3-year-old 4.2-inch fish. You can see the growth rings indicated with the blue arrows. We performed blind reads on both structures by 2 separate readers. Obviously, there are not many experts available to read MadTom otoliths, but both of these readers who performed these estimates would be considered very experienced at reading otoliths and dorsal spines. The reader agreement was pleasantly high at 88% for otoliths and 92% for dorsal spines. The between structure agreement was a little lower at 82%. Most of this disagreement appears to have come from sample processing issues with the otoliths. Cracking of the otolith and missing the exact middle of the structure easily distorted the image, leading to misleading counts. We have no hesitations recommending the use of dorsal spines cut with separating discs for less lethal age work. Cool water and hungry fish led to favorable diet analysis during this survey. All fish that were examined had identifiable items in their stomach. During our sampling period, northern madtoms fed exclusively on aquatic invertebrates. This figure shows the breakdown of the groups we found. Various stages of Trichoptera, or caddisflies, were the most common and abundant diet item. Ephemeroptera, or mayflies, and amphipods, which were predominantly gammarous, were also very important. The caddisfly were mostly free-living forms from families such as Hydrocycidae. These are net-spinning caddisflies that live in the same type of complex habitat as the madtoms prefer. They are very difficult to sample due to their affinity for structure. This in turn makes it difficult for us to really know the actual abundance of these caddisflies in the river. We are unsure if the madtoms are taking advantage of an abundant prey item or selecting these specific ones for certain reasons. We did see a few shifts in the diet preference during our short sampling window. The caddis and mayfly larvae remained relatively consistent the entire month. At the end of the sampling, we did see the amphipod numbers reduce and an increase in consumption of caddis pupae. We would have to assume the pupae are very vulnerable to predation as they attempt to transition, and it appears the madtoms take advantage. Observations on the surface line up as well, as we observed heavy hatches of adult caddisflies during the final days. Our fecundity estimates, or egg counts, are the highest ever reported for the species. The average count for all females was 177 eggs. Egg counts did increase with the total length of the fish, but the best relationship corresponded with the fish's age. Average count by age is shown here. I've included the length frequency plot here to highlight the fact that these fish we are working with are the largest ever recorded for northern madtoms anywhere. The females we examined range from 89 to 137 millimeters in total length, or 3.5 to 5.5 inches. 7% of our total catch is above the published maximum total length for the species. An interesting note is that the northern madtom is reported to spawn at temperatures around 21 to 23 degrees Celsius. In many years, this is the absolute maximum temperature the river ever reaches. This leads us to assume that the water temperature could affect their spawning success from year to year. In 2019, the maximum temperature during our sampling was 14 degrees Celsius. Our observations of the egg conditions were consistent with the actual spawning still being more than a month away. I've laid out here the 4 central areas of the work we completed. The age and growth work was comparable with the few other studies that have completed in this system on madtoms. We did not capture any age 1 fish, and our assumption is the minnow traps we use are selecting for these age 2 and older fish. Being a passive gear, the success of the traps is dependent on movement of the fish, and we assume the small age 1 fish do not travel much. We did document the biggest northern madtoms ever recorded to our knowledge. We recommend the use of dorsal spines for less lethal age work and growth work. This does conflict with previous work that was done in the Detroit River, but our sample size was much larger and did utilize different methods. To date, we have aged 87 Mad Toms. The diet analysis was comparable to studies completed in the 90s with the same primary groups of invertebrates involved. We did observe a shift in the type of caddisflies consumed and are still trying to determine why that might be. The fecundity estimates were much higher than previous studies, but again, our fish were substantially larger than those fish. These previous studies were also performed in small rivers or streams. The available food and the habitat appear to be producing ideal conditions for northern Mad Tom in the St. Clair River. All signs point to a strong and healthy population. We do currently have genetic samples being worked up to hopefully give us insights into the diversity and genetic history of this population. We're also planning work to quantify the effects of removing the dorsal spine from these fish. We would love to be able to expand this work throughout the entire year and also into the shallow water habitat to better complete the entire picture. We're also planning to use these same methods in the Huron River this year. Thank you for attending my virtual talk. I would love to hear any feedback, questions, or suggestions you might have about this work. Thanks again.
Thank you, Brad. So next up is the Michigan DNR research biologist, Andrew Briggs, and he's going to talk about the effects of recreational fishing on lake sturgeon.
Hello, my name is Andrew Briggs, and I'm a fish biologist with the Michigan DNR out of the Lake St. Clair Fisheries Research Station. Today I'm going to talk about the recreational lake sturgeon fishery we have here in the St. Clair system and the trends we've seen and whether we've detected any effects of the fishery on the sturgeon population. Before getting started, I'd like to first acknowledge my co-authors on this talk who are listed on the screen below the title. As I'm sure most of you know, lake sturgeon are a threatened species or endangered species across the range. However, there has been a lot of restoration work and restoration plans developed to help restore these populations. The plans developed often cite a desire to allow for a recreational lake sturgeon fishing opportunity, with a couple examples shown here. The top example comes from Michigan, and the Michigan Sturgeon Plan, and the bottom comes from Missouri Sturgeon Plan. So in the St. Clair system, we're lucky enough to actually have a sturgeon fishery that we can observe and help provide information to managers who may be interested in developing a fishery in their bodies of water. Our current regulations allow for lake sturgeon fishing between July 16th and September 30th, with a slot limit between 42 and 50 inches. Also, a catch and release season continues until March 15th of the following year. Our fishery is unique from other sturgeon fisheries in that both hook and line and harvest is allowed. Also, there isn't an intensive law enforcement presence during the open season, and there are no additional fees to participate as there are in some other places that allow sturgeon fishing. So the objectives of our study here was to determine the characteristics and trends of our sturgeon fishery in the St. Clair system and look at any effects the fishery may be having on the population, which will help inform managers here and across the range of lake sturgeon. For this, we used several data sources, which are depicted here with some photos. Starting in the top left, we used our sturgeon tagging database from our surveys. Also our angler recapture database. This is a sturgeon patch that we hand out to anglers that recapture one of our tagged fish. The master angler database. Our harvest database is anglers that harvest the lake sturgeon are required to report it to the Michigan DNR. And lastly, our angler diary program, where anglers can voluntarily keep a diary of their fishing efforts. So now I'm going to jump into the results that we found. First, the angler demographics. Sturgeon anglers in the St. Clair system came from 8 different states and provinces and 37 counties within Michigan, although the 3 nearest counties to the system, which are Macomb, Oakland, and St. Clair counties, they contained 72% of all sturgeon anglers, and 89% of the sturgeon anglers in the system were male. During the time of the analysis for this work, 359 individual anglers were noted, with 62 or 17.3% being recaptured or recorded multiple times in the databases we kept. Also, using a model, we estimated there's about 944 lake sturgeon anglers that participate in this fishery, with a 95% confidence interval of about 700 to 1,200 anglers. Over time, we have seen participation in the fishery increasing. The retention of anglers in the fishery, or The probability of them fishing again has been consistent over time, but the probability of new anglers joining the fishery has been increasing, which is what this figure here shows below. It has an increasing trajectory over time. Similarly, trends in master angler lake sturgeon has been increasing over time. Harvested lake sturgeon reported has been increasing over time, and reports of angler recaptured fish has been increasing over time. So all these metrics together all support the notion that participation in this fishery is increasing. Angler catch rate, which was measured using Angler Diary Program data, was about 0.07 lake sturgeon per rod hour, with anglers reporting between 0 and 0.2 lake sturgeon caught per rod hour of fishing. This may seem kind of low, but if you consider that each angler is allowed 3 lines, and most sturgeon anglers do take advantage of the ability to use multiple rods, as seen with this 18.7 rod hours spent per trip, this equates to about 1.3 lake sturgeon caught per trip, which is pretty good for a trophy fishery like lake sturgeon. It also isn't uncommon for anglers to report catching much more than this per trip as well. We also did not see a trend in lake sturgeon catch rates over time, which if there was an impact on the fishery, you would probably expect there to be a declining trend in the catch rate. Based on angler harvest of recaptured fish, only about 15% of harvestable lake sturgeon, so those caught during the harvest season and within the slot limit, were reported harvested. This is likely an overestimate as well, since anglers are required to report harvested lake sturgeon, but are not required to report tagged lake sturgeon caught. The average reported harvest per year has been 6.2, but it has been estimated that only about half of lake sturgeon harvested are registered correctly. So if you applied a correction factor to this, that doubles to 12.4 sturgeon harvested annually. And the maximum harvest reported has been 14, which would be corrected to 28. Using these corrected values, that equates to about 0.16% of the lake sturgeon population being harvested annually, with a maximum harvest of 0.37% of the population. When looking at population effects, we found that over time, survival of lake sturgeon was constant, so the fishery did not seem to be increasing lake sturgeon mortality significantly. We also wanted to look into hooking mortality by comparing recapture rates of setline caught lake sturgeon during our surveys, which we know is very low from acoustic telemetry studies, to the recapture rates we see on lake sturgeon after they were caught by anglers. If catch and release mortality was having an effect, we'd expect angler caught sturgeon to have lower recapture rates than our setline caught lake sturgeon. While our setline caught lake sturgeon recapture rate was about 21%, and when we compare that to our angler caught sturgeon recapture rate, it was actually higher at 30%, which suggests that the catch and release mortality isn't higher than what we see on our set lines, which we know is extremely low. So I'm going to jump to the discussion and discuss what these results mean and wrap up the talk. So overall, we saw no negative effects on the lake sturgeon population, and this was despite an increasing participation in the fishery. This was likely a result of low harvest rates and high participation in catch and release by sturgeon anglers. We also found that exploitation was low and below the 2% recommended threshold in the lake sturgeon management plan for Michigan, with there needing to be about 153 lake sturgeon harvested to reach that threshold. I mentioned we saw increasing participation in the fishery, and this is especially true in recent years. We also saw that the geographic footprint of these anglers is increasing since they are coming from other states and counties not surrounding the fishery. However, there is still room for more growth, as 89% of anglers were male. You can compare that to 73% of all anglers being male in the US, so obviously there's plenty of room for more female anglers to join the fishery. Also, since this fishery is in a large metropolitan area, there are obviously a lot of anglers around that could participate in this fishery but haven't done so yet. So why have we seen this increased participation in the fishery? Some potential reasons include increased use of social media since our study began. It's now much easier for sturgeon anglers to share their experience with a larger audience of anglers. Also, catch and release fishing seems to be becoming more and more popular over time, particularly for trophy fisheries. A couple of their examples of this are smallmouth bass and muskie fishing in Lake St. Clair, which are mostly catch and release fishing. Also, we've had simplified requirements to fish for sturgeon over time. We used to need a separate sturgeon tag to fish for sturgeon, and even though it was free, it was still an additional hassle for anglers to get. Also, harvest registration is now easier, with there being online and phone registration options rather than just in-person registration. Lastly, there are sturgeon patches given to anglers that recapture a sturgeon. And these patches have been changing every couple of years or so and have become a collector's item for a lot of sturgeon anglers in the system. There have been several benefits of this fishery as well. Obviously, with more anglers participating, there's increased economic benefit as anglers support small businesses such as restaurants, gas stations, and bait shops, along with natural resource agencies. This is important as this fishery is increasing at a time when fishing as a whole seems to be declining across the country. Another benefit is that the fishery seems to be creating a conservation-engaged angling community. An example of this is Sturgeon for Tomorrow, whose membership is made up of mostly lake sturgeon anglers. They recently purchased some research gear. You can see in the picture a pit tag reader they purchased for us, which is something we need for our lake sturgeon research. So they are obviously a very active participant in conserving lake sturgeon in the system. Now, there are still considerations to be made for managers of other water bodies looking to start a sturgeon fishery. Just because we don't notice an effect here in the St. Clair system does not mean that there wouldn't be an effect in other areas. Managers should consider the health of their sturgeon populations. We have a large stable population here in the St. Clair system, which obviously helps a lot. Also, angler attitudes. Our anglers largely practice catch and release, but anglers in other areas may be more interested in harvest. Also, having a monitoring program is important so that you can ensure that you notice if fishing is negatively affecting the population. Another consideration that we think is important is the possibility of angler success. Since fishing is so good in our fishery, we believe that anglers can more easily develop an appreciation for the species and are more likely to practice catch and release, whereas if it takes a lot of trips to catch one lake sturgeon, the anglers may have a feeling, well, I spent this much time trying to catch this fish, I might as well keep it. Before wrapping up, I'd like to thank the crew of the RV Channel Cat for helping collect data, Justin Chiat with U.S. Fish and Wildlife Service for assisting in sturgeon population estimates, St. Clair Detroit River Sturgeon for Tomorrow for their conservation efforts and for allowing me to use a lot of the fishing photos you saw in this presentation, and to anonymous reviewers who reviewed a manuscript version of this presentation, which if you'd like to see the manuscript, feel free to contact me. And with that, I'd be happy to take any questions. Thank you.
Thanks, Andrew. I appreciate that information on lake sturgeon. Go ahead and enter your questions in the Q&A, and we'll get to those after we hear all of our speakers tonight. I know that the reef restoration in the corridor has also had an effect on lake sturgeon, as well as other fish species. So let's hear about that now from Todd Wills, a research biologist supervisor with the Michigan DNR.
Good evening, everyone. Thanks for tuning in to tonight's Spring Fishery Workshop. I'm sure many of you have heard of the reef construction that has occurred in St. Clair and Detroit rivers, and I'd like to take this opportunity to tell you about how the partners behind these projects are evaluating them. Specifically, the focus of this talk will be how habitat conditions at the reefs change through time, which can ultimately influence their use by fish. So let's begin with a little background information and talk about why reefs are built in the first place. It's about bringing back habitat that was once prevalent throughout the St. Clair-Detroit River system. Fisheries managers believe that recovery of native fish species throughout the corridor, and for that matter the entire Great Lakes Basin, is limited by the loss of spawning habitat resulting from human disturbances, including sedimentation, channelization, gravel mining, and shoreline development. Therefore, substantial resources have been invested to enhance reproduction of native fish populations by creating habitat that mimics the natural reefs once present throughout the basin. Given that investment, we want to be sure that we're getting the most bang for our buck. The newness of this habitat enhancement work in such large rivers, combined with the dynamic nature of these water bodies, makes post-construction assessment of reef sites a necessity to guide future fisheries management efforts and determine project success. However, the size and physical characteristics of these rivers make such follow-up monitoring a challenge. Sonar provides a low-cost solution to this dilemma, as it's a rapid and repeatable remote sensing technique that can provide quantitative results for analysis. We use an off-the-shelf sonar unit, the same technology that's widely available to anglers, to produce a combination of data, including depth, or bathymetry, and bottom hardness as well as side scan imagery. There's also readily available software for these systems that can process the data and produce images that are used to assess changes in depth in substrate or bottom condition. It's an incredibly efficient technique for assessing the investment that's made in constructed reefs. How do we do this? In a day, we can travel to about 1 to 2 sites with our small 20-foot research boat. We follow a survey grid that overlays the reefs and is saved in our chart plotter on the boat for navigation. From there, we drive back and forth over the lines, kind of like mowing the lawn, while recording data to an SD card that's in the sonar unit. Once the data are back at the office, they're downloaded from the SD card and processed with software that uses some fancy math to generate images of depth and bottom hardness. The data that form the images can then be brought into other software for further analyses, like determining how much depth and bottom hardness changes from one year to the next. This is a 3D bathymetry or depth image that is from Grassy Island Reef in the Detroit River. Here's an example from the Middle Channel Reef in the St. Clair River. This is side scan imagery that was captured in June 2012, and it shows the reef immediately following construction. The individual reef beds, as well as a downstream boulder field, are easily distinguishable, as is a substantial amount of moving bed load. And that moving bed load is represented by these wavy brown lines that can be seen both upstream and downstream of the reef in this image. Less than 1.5 years later, the movement of sand over the reef and the infilling of the reef bed is noticeable, which continued and covered more of the reef through the following years. And that's presented in this figure. This figure shows the relative hardness of the bottom at the Middle Channel Reef from 2012 to 2015. And what we see with this graph is that through time, the lines shift from the right, or the blue line in 2012, left to the purple line in 2015. And that indicates that the relative hardness of the bottom actually got softer as that sand infilled the reef. So determining the rate and amount of this change, which is a process that's known as reef maturation, is important for future restoration efforts. In other words, we can apply the lessons that we've learned from the Middle Channel Reef to make other projects better. One of the biggest lessons learned from the Middle Channel Reef is the need to consider natural river processes and for comprehensive pre-construction habitat assessments to evaluate existing site conditions. The moving bed load in the area of the Middle Channel Reef was obvious on the post-construction side scan image that was on the previous slide, and it greatly reduced the hardness of the reef through time as seen in this figure, which is from a recently published paper by my co-authors. These data were not available prior to the construction of the Middle Channel Reef, but they're now part of the standard pre-construction evaluation within the St. Clair Detroit River system and beyond. Such pre-construction data collection and site planning really pays off. Here are some more data from the same paper. Reefs placed with consideration of river processes, including flow patterns and sediment transport, have a higher percentage of usable reef area for a longer time than reefs that did not consider such characteristics. Check out the percentage of usable reef area at the Middle Channel Reef mentioned earlier relative to other sites where substantial pre-construction evaluation took place, like Grassy Island, Hart's Light, and Point Auchene Reef. In summary, sediment accumulation was observed at all reefs, and each reef showed a variable and unique maturation trajectory. That's to be expected in water bodies that are so large and dynamic. Will this cause the amount of coarse substrate preferred by spawning fish to decrease with reef age? Fish spawning still occurred throughout the project, as indicated by continued collection of eggs from the reefs. Data collection is ongoing, and this long-term assessment continues to inform other reef construction projects throughout the Great Lakes. This work would not have been successful without the cooperation of many collaborators, and I'd like to acknowledge them here. I'm also happy to take any questions that you may have. If you'd like to learn more, I can get you a copy of the paper that I mentioned earlier. Just let me know. Thanks very much.
Thank you, Todd. Let's keep those questions coming in the boxes below. Next, we'll have 2 presentations on new regulations being proposed. So first is Jim Francis, the State Administrative Manager with the Michigan DNR, who's going to discuss spearfishing.
Good evening. My name is Jim Francis, and I'm the Lake Erie Basin Coordinator for the Michigan DNR Fisheries Division. And tonight I'll be giving you a presentation that provides an overview for a proposed statewide regulation change under consideration. Underwater spearfishing is currently legal in the state of Michigan right now. However, the Michigan Spearfishing Association was looking at expanding the type of species that can be targeted in an effort to expand fishing opportunities. Now remember, fishing regulations in the state of Michigan are established through the Natural Resources Commission. So that's where the association started this process. They talked to the Natural Resources Commission in April of 2019. At that point, they were advised to work with Fisheries Division to evaluate the merits of this proposal. And one of the things we do whenever we look at any proposed regulation change is we try to get public input into the process. So we've got a number of opportunities through our citizens advisory committees, through our conversations and coffee, through fisheries workshops, to take a proposed regulation and take it to the public and try to get feedback and see what people think, whether there's merit in the process or not. So that's where we're at right now in this process. We're bringing it forward, and this is taking place at a statewide level. So all across the state, we're taking input and seeing what people think about this proposal. And this last bullet here talks about the timeline. So this would go to the Natural Resources Commission in the fall, and if it were approved by the commission, it would go into effect in April of 2022. Not everybody is familiar with spearfishing, so this short video provides a good overview of the activity.
And to do it safely.
You can do, you can use scuba gear, or you can just use regular snorkeling gear or free dive gear. You don't need a ton of this just to get started. I use this because I start earlier and I go later. So, you know, you get a nice wetsuit like this to keep yourself warm, especially in the Great Lakes. Lake Huron, Lake Superior, Lake Michigan are all going to be cold most of June, and into, you know, starting into July and August, they'll get warm. But after that, you know, you can just go in swim shorts and, you know, a mask and fins. But I invest a little bit more myself just because I do it more often and I enjoy it more. So you get a nice wetsuit, some booties, keep your feet and hands warm, a nice mask that you can use, and then a snorkel. You need a weight belt just to counteract the buoyancy of the wetsuit. This is just a stringer, essentially, that you can just clip onto your weight belt, just so you don't have to go back to your dive raft every time. Always important to have a very sharp dive knife, because you will encounter anchor lines and braided line and stuff like that on rocks, and if you ever get tangled in it, you're going to need a way to free yourself. So a sharp knife is very important. With a spear gun, it's pretty simple. All you're going to have here is a trigger mechanism, and then you're going to have a shaft, right? And this shaft is attached to a lanyard, which according to the Michigan regulations can't be more than 20 feet long, but most of the time from back of the gun to the end of the spear is like 15 feet. And then you'll have 2 or 1 band, however you prefer. And then these are what you actually will load physically onto the spear shaft. And that's what will propel it. So that's when they say rubber propelled, that's what they mean in the regulations. This is the rubber propelled propulsion.
Well, we were having a tough time finding fish, but on the plus side, the guys were able to remove some trash from the area. Although spearfishing may sound easy, in reality it can be quite difficult. Thankfully, John had captured some footage of his own recently and was able to share it with us to showcase what it looks like when things go well.
Okay, I thought that video provided a pretty good overview because not a lot of people have a good understanding of what spearfishing is. So that did a pretty good job. So now the specific proposal at hand. So this is exclusively for the Great Lakes. So again, for our area in Southeast Michigan, that does not include the connecting waters. So St. Clair River, Lake St. Clair, Detroit River are not included. It's only for Great Lakes proper. So Michigan, Superior, Huron, and Erie. So currently there's no closed season in the Great Lakes for spearing, and there's different species that you can target. So for example, bowfin, bullhead, burbot, carp, catfish, cisco, drum, gizzard shad, goldfish, grass carp, long-nosed gar, smelt, suckers, and whitefish. So that's currently what is allowed. So this proposal would look to expand those species to include northern pike, lake trout, and walleye. Now, in addition, they're proposing to have a season, so it would be the last Saturday in April through September 30th, and that's in compliance with our current regulations. So, for example, on Lake Erie, there currently is no closed season on walleye. So this doesn't expand any opportunities, and furthermore, this proposal would not, it would have the existing minimum size limit and possession limit for these species. These next couple of slides provide more detail related to this spearfishing proposal. So first off, related to gear. So you would be allowed to use a rubber or spring propelled spear gun or pole spear. And as was noted in the video, the spear must be attached to a line not exceeding 20 feet in length. And this proposal would also limit the type of gear that would be allowed. For example, you would not be allowed to use artificial breathing devices such as scuba or rebreather. This would only pertain to snorkeling or freediving. The Spearfishing Association thought that there might be some safety-related concerns to the spearfishing proposal, so they included some additional safety regulations that would go with this proposal. So for example, there would be 150-foot setback from designated swimming areas, boat docks, or power intake tubes. And it would also limit where you could use your diver down flag so that it couldn't be used in a way that would restrict navigation or access to boating access sites. And there would be special regulations on the gun itself. It would not be, basically would have to be unloaded when you were entering or exiting the water. And I'd be happy to open it up at this time for questions and hopefully to have a discussion on this topic. Thank you for your attention.
All right, thank you, Jim. So now we're going to go ahead and go on to our second proposed regulation change with Sarah Thomas, who's a DNR fisheries manager, and she's going to provide some more information about walleye minimum size limits.
Good evening. I'd like to talk to you about several walleye regulation changes that are at various stages of implementation and due to various reasons that I will discuss in several slides for the St. Clair Detroit River system. So what is the scutters when we refer to this? And that is the St. Clair River, Lake St. Clair, and Detroit River, the entire corridor between Lake Erie and Lake Huron. And so if we take a look at the walleye in this system, we know that migration is a really large part of this. Lake Erie walleye are highly migratory. We know this from numerous tag studies that have been done. Substantial migration occurs after spawning, which generally occurs in the tributaries and the western basin along the reefs. Walleye move from across western Lake Erie through the Huron-Erie corridor, which we now refer to as scutters. And walleye that have been tagged in Lake Erie have been recovered from numerous water bodies, including southern Lake Huron, Saginaw Bay, and even as far as the Straits of Mackinac. And so if you ever catch a tagged walleye, this is what it will look like, and we need this information reported to us. So if we take a look at these tagged fish and walleye, we know that the Lake Erie walleye stock is an important source of walleye for scutters and beyond. These Western Lake Erie walleye are the dominant fish that are in the system. At least since 2000, the former stock in the Thames River on the Canadian side has been very depressed and is no longer a major contributor to the fishery due to poor recruitment. Similar on the US side, the rivers such as the Clinton and the Huron just really aren't big producers of walleye due to the habitat and dams. So despite scutters being made up of basically one stock, the Lake Erie walleye stock, we have had a very big mix of regulations through the years, and the St. Clair River, Lake St. Clair, Detroit River, and Lake Erie have all had pretty varied regulations, particularly since 1983. Statewide has been similar for a long time, since 1976, and we're still at that 5-fish, 15-inch bag limit. But if you take a look at our other systems here, Lake Erie and Detroit River and St. Clair River, they're pretty different. Particularly in 2004, and this followed the walleye crash in 2003, where DNR and other management agencies around Lake Erie took drastic measures to reduce the walleye harvest and try to conserve the spawning stock. So for those 2 years, the fishery in both the Detroit River and Lake Erie were closed from April through May. The bag limit was reduced and the minimum size limit was bumped up to 15, corresponding to the statewide. What didn't change, however, was the St. Clair River and Lake St. Clair system, primarily a driver of social issues, but from a biological perspective, being that those were Lake Erie fish as well, that really should have been reduced as well. So the walleye population did rebound, and regulations were changed again in 2006, and year-round fishing was open again in the Detroit River and Lake Erie. And then a new quota allocation was derived in 2011, and Lake Erie bumped up depending on what our total allowable catch is, and we currently are at 6. What never changed and got stuck kind of in the middle there was the Detroit River that stayed at that statewide 5-fish, and then the St. Clair River and Lake St. Clair remaining with those odd regulations of a bag of 6 fish and a 13-inch minimum size limit. So we started to discuss this, primarily focusing on Detroit River and wanting people to be able to harvest more than that 5 fish. So this started way back in the fall of 2018, and even before then, we discussed with our citizens advisory group, and they took initial discussions back to their angler groups to gather feedback. We brought more specific options in the spring of 2019 that were discussed and approved at the citizens meeting and our public coffee and conversations meeting. We then wrote up those proposals in the summer of 2019, and they were reviewed in the fall of 2019 by the Natural Resources Commission. And so then those take effect the following regulation year. So in spring of 2020, the new walleye regulations for bag limit only came into effect for the entire Scudder system. So basically what we changed, and the rationale behind this, was that if walleye are reduced enough in Lake Erie that it triggers a bag limit reduction, then the catch should be reduced for the entire Lake Erie stock, which would include the entire St. Clair Detroit River system. This went into effect on April 1, 2020. The bag limit in the entire Scudder system is now tied to the Lake Erie bag based on our total allowable catch. So we are currently at 6, and I don't want people to worry. We're going to be at 6 for quite a while. There's so many walleye swimming out there that based on the annual limit of a 20% change in the total allowable catch, we wouldn't be reduced below 6 fish for quite a while. So the other thing that we had discussed and approved back in all of these discussions in 2019 was a uniform minimum size limit throughout this system as well, and changing everything to that minimum of 15 inches that we see in Lake Erie and also is the statewide. However, I did convince Jim and other folks to hold off on that minimum size limit proposal for 1 year, and I'll get to why I requested that in the next few slides. So originally we had planned to submit this in spring 2020, but the Natural Resources Commission last year, with all of the COVID issues and not being able to have public meetings, asked us to vastly reduce the amount of proposals that we brought to them. So therefore, we're reminding everybody of these discussions and our proposal to submit a minimum size limit and collecting final public feedback. So if we take a look at this, this is the Western Basin Lake Erie Walleye class strength. So how strong the age 0 fish are born each year, and hopefully those, translate into stronger recruitment to a fishery in several years. And so if we take a look at this, recruitment was quite variable and about average through the 1990s and 2000s, with the exception of a really large year class in 2003, which kind of saved the fishery from crashing. And then in 2018, we had a record year class in the Western Basin, followed by a pretty strong year class in 2019 as well. So really high recruitment recently starting in 2018. And so all of those 2018 fish, if we implemented the change in the minimum size limit, most of those would not have been the quite 15 inches in the year that would have been forward, which was why we delayed it 1 year, and then it got delayed even 1 more year because of COVID-19. So I don't have the most recent data, but if we take a look at 2016 through 2018 and looking at the size of walleye harvested from our Lake St. Clair biological data and creel data, we can see that as this 2015 year class, which was the biggest prior to 2018 for the last several years, showed up, we're getting a huge increase in the number of 15+ inch fish harvested, and that's because those fish are now reaching that 15-inch size limit. So we expect very similar things with those new year classes that we're seeing coming on as well. So one of the reasons that we are concerned and wanting to look at changing the minimum size limit to 15 is the maturity of these fish. So at a 13-inch size limit, there are more males that are mature at 13 inches, but we get a way bigger increase if we bump that up to 15 inches. And for females, less than 2% are mature at 13 inches, but more than 4% are at 15 inches. And while that increase may not seem like a big deal, the reproductive output of females is much more important than males. So any increase that we can get in those females will ensure strong reproductive classes as we move forward through the future. So moving forward with this increase in minimum size limit that got delayed, but that everybody got on board with and approved in the last several years, and making the consistency in regulation. So although we recognize that both the 13-inch and the 15-inch minimum size limit do result in some immature females being harvested, that the gain that we get from the increased females that have eggs and are ready to spawn at 15 inches will be good for the future. And if we take a look at it in a different way, the only other place that has a 13-inch minimum size limit in Michigan for walleye currently is Saginaw Bay. And the stated management goal behind that is to reduce walleye abundance, and that is not necessarily one of our goals in the St. Clair Detroit River system. So, like I said, various reasons why this proposal was not directly moved forward with the bag limit, but we're at the case now where we can do that. So currently with the changes, the regulations that are on the books right now, all of these water bodies, St. Clair River, Lake St. Clair, Detroit River, and Lake Erie all have that bag limit that will be the same and consistent and is tied to the Lake Erie quota. And then with this proposal, the minimum size limit would be consistent across these water bodies as well at 15 inches. So we're just soliciting final public feedback before we present this to our internal division regulation committee and then move it forward from the Natural Resources Commission from there. So the overall question after all of this is, do you support consistent walleye minimum size limits across the entire Scudder system? That would be 15 inches for all 4 water bodies in St. Clair Detroit River system. Yes, you support. No, you do not support. We can have you enter your comments along with any points for and against that you would like to make in the comment section or question and answer, depending on what the awesome folks at Sea Grant told you. So I appreciate your time, and if there's any questions, happy to answer them. Thanks.
Okay, well, thank you, Sarah. So next up, we have Cleo Harris, MDNR fisheries biologist, and he's here to share an update on the Lake St. Clair habitat projects.
Hi, my name is Cleo Harris. I'm a fisheries biologist with the Michigan Department of Natural Resources Fisheries Division. Today I'm going to share some information about habitat projects going on in Lake St. Clair. When you think about the habitat on Lake St. Clair, you might think about the vast amount of open water there is, or you might think about some of the vegetated areas, woody material, rock pilings, places where fish really like to hang out. Your head might go to some of the human impacts, hardened shoreline, some of the negative impacts that we've had out on the lake. Or you might think of human habitat. Where do we like to go hang out? Maybe your mind goes to the St. Clair Delta, where there's a vast amount of coastal wetlands and nearshore natural habitat. But no matter where your mind goes, Lake St. Clair has a lot of habitat. Unfortunately, it's not all created equally. And it's not all as productive or as beneficial to the fish community as the coastal wetland that you see at the bottom of this slide here. So when we think about habitat projects on Lake St. Clair, we look at places where we can have kind of the biggest bang for our buck. Where are we going to have that biggest impact? And that points us to the near shore and coastal wetland areas, where as people, we've had a lot of impact, and near shore and coastal wetland areas are often the most productive places in the Great Lakes as well. So this is identified through the Lake Erie environmental priorities by the Lake Erie Committee, focusing towards increasing the shoreline and nearshore complexity, through the softening of shorelines, rehabilitation of connected coastal wetlands, and increases in submerged aquatic vegetation. The projects I'm going to show you today are located in those nearshore and coastal wetland habitats. First in the nearshore, looking at the Clinton River Mouth Project, Brandenburg Park, and then we'll go to Ford Cove. And then for the coastal wetland projects, we'll look at Black Creek Marsh and the Salt River, which is a tributary to Lake St. Clair in the Anchor Bay. We'll start with the Clinton River Mouth Project, which is located at the south end of Anchor Bay, and it's a nearshore project. And this is at the area where the Harley Anson boat launch is, as well as our Lake St. Clair research station. And these projects are really collaborative, so there's a lot of partners and a lot of specific skill sets that get brought to the table here. So for this project, we have the Michigan Department of Natural Resources, Army Corps of Engineers, Eagle, Cardno, which is an engineering firm, and the Clinton River Watershed Council. This project had a lot of terrestrial and aquatic components to it. Focusing on the aquatic side of things, there was a lot of effort put into trying to create a gentle slope going out into the lake that would allow the emergent and submerged vegetation to kind of fluctuate with the Great Lakes water level. So as it got drier, the emergent vegetation would become more dominant in that nearshore area and go out further into the lake. And as the water levels got higher like they are right now, the submerged vegetation would get closer to shore, creating an optimizing that nearshore habitat, which is really beneficial for a lot of fish species in the Great Lakes, especially Lake St. Clair. So in the diagram on the top, you can see kind of the concept that we were going for there, where we have these whole tree clusters further offshore that would break up that wave energy to protect the rooted material in between in that nearshore zone, so that submerged plants and emergent plants could take root and kind of hold in and not get really disturbed by all the energy that does get brought in by the wave and wind energy. There's a lot of other habitat components to this project. With invasive species management, there's a lot of terrestrial components to it, as you can see in the bottom picture, where we wiped out a lot of the Phragmites that covered the whole point, and there's some different structural components to it as well. But that nearshore piece for fish habitat was the most important and does help a lot of the productivity in that area, and was definitely a benefit to the lake. Next, we'll move up to Brandenburg Park, which is also a nearshore project and located in Chesterfield Township, kind of in the middle of Anchor Bay. Brandenburg Park is a 17-acre park with about over 700 linear feet of shoreline in front of it. And this project was partnered with Chesterfield Township, NOAA, US EPA, the Great Lakes Commission, OHM, which is another engineering firm, Eagle, and of course the Michigan DNR. So a few years ago, Chesterfield Township identified that the seawall is starting to fail at Brandenburg Park. And as you can see in this picture, once it failed, there was a lot of erosion that occurred because of the wave energy kind of getting through that seawall, and it wasn't protecting the shore behind it anymore. So instead of just slapping another seawall in, Chesterfield Township came to a bunch of us partners and was asking for ways that we could look at a habitat project to soften it, because a seawall that's almost, over 700 linear feet, it's going to be pretty expensive. So why don't we look at options to improve habitat for the fish community and other animals in that area, as well as providing an educational opportunity. So what you see here is a conceptual drawing of the work that's actually going on at Brandenburg Park right now. One of the main focuses was trying to reduce the amount of wave energy that hit that near shore zone as well as the shoreline, similar to what we did at the Clinton River mouth. This is a little bit different because we're using stone shoals instead of log clusters, but just creating a more beneficial nearshore zone with a lot of habitat improvements on the inside between the shoal and the shoreline, as well as plantings and a different slope on the shore so that it can be a softer shoreline there as well. So a lot of really good habitat components in this project, including some deeper water that's going to benefit fish like largemouth, smallmouth bass, juvenile muskies, perch, panfish. It'll be really beneficial for a lot of species in Lake St. Clair. And we've been working on this since the fall. So a lot of the in-water work has been done throughout the winter, and this picture was actually taken in the middle of March. So the seawall, since that time, the seawall has been removed. You can see the excavators working on shore. And then you can see some of the waves breaking a little ways offshore, and they're actually breaking because they're hitting those stone shoals. So the wave energy is starting to dissipate way offshore, so it's a lot less by the time it gets into that nearshore zone, which gives it a little more chance for the shoreline to stay with vegetated, as well as the vegetation in that nearshore zone to stay rooted and stay in place. Next project I'll talk about is the Ford Cove project, and this is actually in a feasibility stage. So we're just collecting data at this point right now, but this is located down by Grosse Pointe near the historic Ford House. And this project covers about one mile of linear shoreline when you take into account the island. And we have a number of partners for this one as well: Ford House, NOAA, US EPA, Great Lakes Commission, OHM, Macomb County, Eagle, and Michigan DNR. So this project is going to have a lot of similarities to the Brandenburg Park project, where we're going to be looking at shoreline restorations, some nearshore habitat improvements. We'll also look at wetland enhancements and marsh restorations to go as well. And this is at the feasibility stage again, so we're collecting the information to see what we should do, what can we do, and how much that might cost. So more information will be coming out on this project in the future. So we're going to move on to a couple of the coastal wetland projects. We'll start with the Black Creek Marsh, located in the Lake St. Clair Metro Park. And you can kind of see the marsh in this area here, just north of the boat launch at Lake St. Clair Metro Park. And this had a lot of partners as well, Huron Clinton Metro Park Authority, Macomb County, Clinton River Watershed Council, Wayne State University, Oakland University, ASTI, which is an engineering firm, and the DNR as well. What we have here are two aerial images. On the left, it's from 1990, and this is the Black Creek Marsh. And on the right, it's from 2015. And again, this is the Black Creek Marsh. And what you can see in 1990, there's a lot more open water than there is in 2015. And that's because 1990 is before Phragmites got established in the area. So by the time in 2015, when Phragmites was well established and pretty much took over the whole marsh, the amount of aquatic habitat had really been reduced. So that's what this project was about. It was trying to eliminate the invasive species in the marsh, as well as opening up the amount of aquatic habitat. And that really benefits fish a ton, from northern pike going into spawn or perch spawning, and available nursery habitat for juvenile species as well. So we fast forward to today, after we've seen Phragmites pretty much wiped out of the whole marsh, plus some canals cut into the marsh to increase the amount of aquatic habitat available for fish species. And we've really seen the population respond with higher numbers in some of our post-monitoring efforts as well. So now we're going to move back up into Anchor Bay on the Salt River. So this is on the Salt River just upstream from Jefferson Road, where we have the Salt River Marsh State Wildlife Area. And this project also has a lot of partners: Army Corps of Engineers, Oakland University, Macomb County, Eagle, and Michigan DNR. And it's similar to, similar to the Black Creek Marsh Project, where Phragmites came in, choked out the wetlands. So we're going to do some invasive species eradication and then management, as well as cut some canals into the wetland areas to increase the amount of aquatic habitat for nursery areas, spawning, and different life stages of a variety of fish species. So with that, those are all the habitat projects I'm going to share with you today. If you have questions about any of these, want any more details, are interested in other opportunities for habitat projects around the lake, by all means, reach out to me. This is my email address and my work cell phone number. I'd be glad to talk with you further. Thank you.
Thank you, Cleo. Good evening, everyone, and welcome to the final presentation for the evening. We just heard all about the exciting Lake St. Clair habitat projects. Now it's my turn to brag a little bit about some of the Detroit River ones. First, let's talk a little bit about the history of the river. In 1815, coastal wetlands lined both the U.S. and Canadian shorelines of the Detroit River, shown here in bright green on the left. By 1982, 97% of those coastal wetlands had been lost due to filling and hardening of natural shorelines and other human activities. The black spots, mostly on the Canadian side of the river of the 1982 drawing, were all that remained of the historical coastal wetlands. One of those other human activities was the creation of the Livingstone Channel. From 1874 to 1968, 60 miles of shipping channels were excavated in the Detroit River to allow for added shipping traffic. Unfortunately, the channel cut through and covered over coastal wetlands as well as historic fish spawning grounds. By 1923, people were recognizing pollution in the river, but still not so concerned about the potential impacts on human health. Industrial pollution got worse before it got better. In 1948, oil-soaked waterfowl carcasses were delivered to the steps of Michigan's Capitol in Lansing in protest of lethal oil pollution in the Detroit River. In the 1960s, the Rouge River, which empties into the Detroit River at Zug Island, was one of 3 Great Lakes tributaries to catch fire from all of the floating oil and grease that had accumulated. Events like this led to the 1972 Clean Water Act, with a very lofty goal of zero discharge of pollutants into the nation's waters by 1985. And in 1987, the amendments to the Great Lakes Water Quality Agreement between the U.S. and Canada established the Areas of Concern program. With the passing of that amendment, the Detroit River, along with 42 other Great Lakes areas, was designated as an area of concern. The designation was based on 11 conditions that led to the loss of certain beneficial uses of the river. 2 of those are directly related to habitat. A guidance document for removing fish and wildlife-related beneficial use impairments was completed in 2009 and updated again in May of 2014. The plan identified 14 specific habitat restoration projects. The projects in blue have already been completed, and work is in progress on those in pink. The Detroit Upper Riverfront Parks project is being managed by the EPA and City of Detroit. Belle Isle Flatwoods is being managed by the Michigan Department of Natural Resources.
The rest of the pink projects, which I'm going to focus on for my presentation, are being managed by Friends of the Detroit River and the Detroit River Public Advisory Council. I've been the Public Advisory Council chair since 2010, so I'm pretty familiar with the projects. We also have my vice chair, the Detroit Riverkeeper, Bob Burns, here tonight. I'm sure between the two of us we can answer any questions you might have. Let's get started with our Lake Okanoka project, which is 99% complete and connects with several other projects on the list that I just talked about, including the Belle Isle Flatwoods that Michigan Department of Natural Resources is managing. The goals for Lake Okanoka were mainly focused on increasing fish nursery habitat and fish passage. Here's a sketch of the project master plan, which includes enhancements from one end of the lake to the other. I'd like to call your attention to several elements that particularly impact fisheries. An improved connection to Blue Heron Lagoon, allowing fish to pass freely between the two lakes, which is under the road between the lakes in the upper right of the picture. Deepening channels and pools throughout the lake, and a new outlet to the Detroit River just downstream from the fishing pier in the bottom center of the sketch. This is an aerial view of Lake Okanoka during the draining process. The existing deep pool on the top right remained undrained throughout the project. Here you can see the lake was deepened in some areas to improve water flow. And turtle basking logs, woody debris bundles, fish spawning gravel, and other habitat structures were placed around the lake. A weir structure with stop logs was added at the southern end of the lake to be able to better regulate water levels in the canals on the island. An accessible kayak portage with docks was installed on each side of the weir to allow kayaks and canoes to get around the weir structure. Now, fish from the Detroit River can enter Blue Heron Lagoon, go under the new road bridge into Lake Okanoka, and eventually re-enter the Detroit River where some new shoals have been constructed. Okay, let's move to the lower end of the Detroit River to talk about Stony and Celeron Islands, which are both managed by the DNR as part of the Point Mouillet State Game Area. The projects are very similar to one another, with design and goals of both to decrease erosion and loss of coastal wetlands and to allow the macrophyte beds to reestablish themselves. Here's a drawing with a list of habitat enhancements for Stony Island. This is what the island looked like before any construction was done. You can see the remains of a road that used to encircle the island. Here's a photo of one of the shoals during construction. Barges full of rock were brought in and offloaded to create the shoals. Smaller gravel was placed on top of some of the shoals to provide nesting habitat for terns and other shorebirds. Other shoals were planted with native plants to provide different kinds of habitat. The southern bay on Stony Island is now protected by shoals that substantially increase the amount of fish nursery habitat that's between the island and the shoals. The Celeron project was similar to Stony with shoals on both ends of the island. These are the southern shoals, again improving many acres of fish spawning and nursery habitats. And this is the northeast shoal with a nesting barrier beach. Now we'll move on to the Sugar Island project. Sugar Island is owned by the U.S. Fish and Wildlife Service and is part of the Detroit River International Wildlife Refuge. It's at the far southern end of the river where wind and waves from Lake Erie regularly erode the island. Here you can see the effects of the current and wave-driven erosion as soil from the island washes into the river. Large hardwood trees are being lost as cliffs fall off into the river. The plan that is currently being explored for Sugar is to create shoals to break up the wave action, reduce erosion, and allow the coastal wetlands, also known as fish nurseries, to reestablish themselves. There are also plans to add shallow, warm water fish spawning gravel areas. The final project is Hennepin Marsh, which is located on the north end of Grosse Ile. We're currently in the feasibility and design phase of the project, so I don't have any drawings or photos to show you yet. We're investigating the possibility of doing habitat enhancements on the north and south side of the Grosse Ile toll bridge. So with that, I'd just like to say thank you for sticking with us and start the question and answer portion of our agenda.
All right, so as you're adding more questions into the boxes at the bottom, we're going to go ahead and put a link into the chat for our survey. If you've been to a fishery workshop before, you know that we always ask for your feedback on our workshops. Your participation helps us make improvements to the workshops and also helps us identify future topics for those workshops. So please complete the survey after the workshop. We'll also email the link to everyone who registered along with the recording from tonight's workshop so that you can share it with others who weren't able to attend. So speakers, if you can go ahead and turn on your cameras.
Yeah, we have a few questions. I'm just going to take them in order as they were submitted, so we might bounce back and forth. The first question that was asked was, why are muskies so stinky?
Who wants to take that one?
Come on, Jan, you handled a lot of muskies. How bad were they?
Can you guys hear me?
Yes.
I don't know. I don't think they're that stinky. Just, I guess it depends on your point of view.
All right, next question.
During the muskie study, did you notice any difference in movements among size or year classes?
No, we didn't. That was one of the things we specifically looked at, was the effect of size, fish sex. So if there were differences among males and females, and also the locations where we tagged the fish. And none of those factors explained a significant amount of variation in the movement. So they were appeared to be the same regardless of size or sex or tagging location.
The next question was, can sturgeon be reintroduced into the river raisin?
Yeah, I can take that. So that's a good question. One thing we'd have to do is check the habitat suitability for lake sturgeon spawning, particularly below the dams in the river raisin. I'm not that familiar with the habitat, but another thing that's kind of working against that is just the location. We're between St. Clair Detroit River system, which obviously has a huge population of lake sturgeon relative to other areas of the Great Lakes. And then south of that is the Maumee River, which they just started stocking sturgeon there. So it's kind of a lower priority system compared to other rivers that haven't gotten the chance to have lake sturgeon restoration yet. So probably could, but probably not going to happen for a while.
The next question is, with a increasing trend in lake sturgeon angling, is the MDNR concerned that there may be a shift from catch and release focused anglers to more harvest focused anglers?
So that's another good question. I guess the short answer would be not yet. Currently, harvest is pretty low at a maximum of 14, or if you apply a correction factor, about 28 lake sturgeon a year. But that's quite a bit lower than that 2% threshold. And we probably have to reach 1% before we really started to think about changing the regs. But the regs currently do a good job at protecting lake sturgeon. The slot limit protects about 80% of sturgeon that are in the system. And the season's pretty short. So I think overall the current regulations does a good job of limiting harvest as well.
So I have a Mad Tom question here. Did water levels, or do water levels make a difference in Mad Tom catch rates?
So none that we saw. Our sites that we are sampling are range from 18, 20 feet deep all the way down to 60 feet. And we do see some differences from place to place, but it doesn't seem like depth really affects that. So they can be found up in shallow water or in even those deep holes, 60, 70 foot of water. So it doesn't seem like the current water level changes have really affected them. They seem to be hanging out in much deeper areas of the river than the water levels would affect them.
Another question on or about the reefs. What materials were used to construct the reefs?
That's a good question. Typically, it's 4 to 8 inch limestone, and the reason for that size is to avoid the sizes of stone that are preferred by invasive species like sea lamprey.
Next question is on the proposed spearfishing regulations. Is there tribal input on that?
Yeah, I'll take a shot at that one, and I guess I'm not. I'll try to answer it. I'm not clear exactly what they're looking for. So this is a sport fishing regulation. So we do consult with tribal fish management agencies when we do have regulation changes. So they do have input at that point. So they I guess the short answer is yes, they do have some input into the process.
Another question about reefs. In areas where large soft sediment or sand flowing along the bottom, have you considered adapting the shape or angles of the rock nursery beds to create self-scouring shoals?
Yeah, there's certainly been some thought put into the shape of the reefs, but I would say that the majority of the efforts, after we learned what we learned from the middle channel, have been avoiding those areas of moving sand altogether, and trying to get those reefs sited in an area where there is less moving bed load, so we don't have that problem.
Next question. Why are northern pike, lake trout, and walleye the 3 new species to be added to the spearing species list? Why not smallmouth bass, rock bass, and yellow perch, white bass, and muskie?
Yeah, good question, Justin. So this was a proposal. What I presented in my recording was a proposal that was presented by the Michigan Spearfishing Association, and this was their proposal that they brought forward. So those were the 3 species that they were looking to get added. Again, as you go through the list of species that they're currently allowed to spear, most of them are what we consider rough fish, carp and drum and those types of species. But as you can see from the video, it's a fair amount of work to go out there and do that type of spearfishing. And so when they're out there doing that activity, they thought it'd be great if they could, if they found one of those other species, they could spear that and bring it home and have it for dinner that night. So that was the thought process. And we did talk to them about why they picked those particular species. And, part of it was to also avoid controversy. So for example, most bass anglers are very diehard catch and release. So they didn't want to propose bass because, they thought there would be a conflict there and that they would have a better opportunity to get this to pass if they kind of avoided some of those species. Probably the same thing with muskellunge as well.
Another question, how do walleye regulations affect the commercial fishery?
Yeah, so if we're talking about Lake Erie, that's where we have our we do manage it through a quota management system. The state of Michigan does not have a commercial fishing operation for walleye in Lake Erie. So the way it works is that we develop a total allowable catch for all the jurisdictions on Lake Erie, and that gets allocated based on a surface area formula. And then each management agency manages their respective fisheries to stay within that TAC. So the only commercial walleye fishery on Lake Erie is in Ontario waters. So, and the regulation change that Sarah talked about was the size limit that was on the St. Clair River and Lake St. Clair. And again, we don't have state commercial fisheries there as well.
And I got one last one that came in through the Q&A. It looks like it might be more of a point of clarification or a comment about the walleye size limit. It seems like the strongest reason for the change from 13 to 15 inches would be to make the size limit throughout the St. Clair Detroit River system consistent from Lake Huron to Lake Erie, especially since there's so much movement throughout the system. I think that was kind of a summary of what was talked about, correct?
Yeah, good comment, Mike. And you're exactly right. It does, as Sarah emphasized, what it does now is it makes consistent regulations across that whole area. So from an angler standpoint, they only need to memorize one regulation. From a law enforcement standpoint, it makes it a lot easier. She did focus in her presentation on some of the biological reasons for it, but certainly simplifying the regulations and making them more consistent, there's a lot of advantages, social advantage to that as well.
So I have a couple more questions here. So is there anyone researching the cumulative impact of habitat projects in the entire corridor? For example, how many acres of coastal wetlands have been added, fish spawning areas, nursery, etc. I'll just say on my end, I don't know of anybody who's doing the entire corridor. Cleo, I don't know if you know of anybody.
There's some initiatives through the Blue Accounting that they're trying to get that off the ground. It's not quite there yet, but there is some focus on trying to do some of that. And from the fish perspective, there's a lot of ongoing surveys that the Lake St. Clair Research Station does, as well as other entities throughout the Huron-Erie corridor. And so they're able to do those index sites to kind of get a gauge on and see if we are making an impact on the overall fish community too, not just at that one location, because that's a really hard thing to point out. Like, did the Black Creek Marsh really have a monstrous impact on Lake St. Clair? You can't tell that just by surveying at that location, but all of these index sites that do go on throughout the course of the year do help provide some of that insight as well.
Yeah, I know that we're always talking about that 90% of coastal wetlands in the Detroit River that's been lost. I don't know that anybody's done any research on what's been added since we've been doing a lot of the work. So that'd be interesting to see. So good question. Another question, this one for Jan. What's the oldest muskie that's been tagged?
That's a good question. I'm not sure off the top of my head. Brad actually might know better than me. We've definitely tagged some pretty big fish, fish approaching 50 inches in size. So can't remember what the ages were on those, but a couple of pretty big ones have been tagged. And the tags that we have last 6 to 7 years, depending on their programming. So typically we're looking for smaller fish that are going to survive, hopefully that entire time and provide data. But we take the fish that we can get. So we've had a couple of larger ones tagged. I can see if Brad, not to put Brad on the spot, but see if he can come up with an age for some of those bigger fish that we've tagged.
Yeah, I don't have it right off the top of my head, but I know that there have been a few 15 and 16-year-old fish. Some of those larger females were 15 or 16. So that is right in that range is where the oldest fish would be that we've got tagged.
Thanks, Brad.
Great. And same question for lake sturgeon.
Yeah, so sturgeon, we're not good at aging them once they get above a certain size. Like we use fin rays to age lake sturgeon, but once they get over about 40 inches, the age estimates become really unreliable. So I'm sure we've aged some upwards of 60 years old, but we don't really know exactly how old they are. I don't know if Brad, you ever aged anything over that, but I know once they get over a certain size, they're hard to age.
No, nothing older than that from our station. There's evidence from other places of them being much older, but same thing. We've got to go with they're at least this old and know we're still underestimating.
All right, and then the last question I see is for the water levels. Mark, what impact do water levels have on the fishery? What are those potential pitfalls with high or low water levels?
I think obviously it depends on the species. Water levels really are generally good for coastal wetlands, right? To have the variations of plants, the emergence do better in some years, and then they're higher levels later. So I think it's going to depend on species, but it depends where you're at. So it's actually an easier question if somebody asks, what are the low lake levels issues? Because then we're concerned about some fish actually making it into any coastal wetlands that were there. And there were some emergency regulations that were put into some rivers back in 2012 because they had lake levels had dropped so much. So generally it's a pretty resilient system, and the fish are used to adjusting to the lake levels through time.
All right, thanks. Did we have any other ones come in there, Justin, that I didn't see?
I don't see any new ones coming in. Nope.
I had a
Okay.
quick question for Todd, if you could. I was curious if maybe USGS or somebody might be able to do multi-beam sonar on the reefs instead of a single beam that you're kind of adding together.
Yeah, that's a good question, Mark. I'm honestly not sure who has that technology and how we could apply it in that situation, given the size of those reefs, the widths being small enough. Like you said, we typically take that single beam approach and stitch it together. Almost to, in essence, create a multi-beam swath with the single beam data.
Thank you.
All right. Well, with that, I'd like to thank everybody for hanging out with us tonight. Hopefully you learned something new about the fishery. And again, thank every one of the speakers for donating your time tonight and, making our fishery workshop a success. Look for a follow-up email for those of you who registered. We will get out the recording as well as the survey. And again, if you have any questions, feel free to contact any one of us directly. So thanks, everyone. Have a good evening.